Hi, welcome to my video on primary trig ratios, part 1. The primary trig ratios are sine, denoted by sin, cosine, denoted by cos, cos, and tangent, denoted by tan. These three trig ratios are in relation to the acute angles. So remember, we're always dealing with the acute angles of a right triangle. To help learn these three trig ratios, you can use what we call SOH, S-O-H, K, C-A-H, TOA, T-O-A, SOHCAHTOA. And the saying for SOHCAHTOA is that S stands for sine, O stands for opposite, and H stands for hypotenuse. So sine is opposite over hypotenuse as a ratio. C is for cos, C-O-S. A is for adjacent, A-D-J. And H is for hypotenuse, H-Y-P. So cos is the adjacent side over the hypotenuse in a right triangle. And T stands for tan. O stands for opposite. And the A stands for adjacent. So this is a saying that I use all the time to come up with my trig ratios, and I have it memorized. SOHCAHTOA, S-O-H-C-A-H-T-O-A. And I always write this down when I'm going to do any trig ratios in relation to coming up with the angles and the sides. So what happens? The sine of an acute angle, notice I'm talking about the acute angle, not the right angle. The sine of the acute angle is the opposite side over the hypotenuse. Sine is opposite over hypotenuse. And the cos of an acute angle, I stress the acute angle, cos is the adjacent side over the hypotenuse. The adjacent over the hypotenuse in a right triangle. And tan, T-A-N, of an acute angle again, stress the acute angle. Tan is the opposite over the adjacent as a ratio. Opposite over the adjacent. SOHCAHTOA, S-O-H-C-A-H-T-O-A. And every time I go to do trig ratios, I will write that down. Let's do some examples. Example, find each trig ratio. So what happens is that I'm going to find, in terms of this triangle, which has angle A, C, B, where C is a right angle, I have the 5, 4, and 3 for the sides. So notice I want to find sine, cos, and tan. Let's do all of angle A first. So I'll write down SOHCAHTOA, S-O-H-C-A-H-T-O-A, SOHCAHTOA. And when I'm looking at angle A, there's angle A. I will write opposite here. I will write adjacent right here. And I will fill in the hypotenuse. So the hypotenuse is 5. Opposite of A is 3. And the adjacent is 4. So sine is opposite over hypotenuse. Opposite over hypotenuse is 3 over 5. The cos is the adjacent over the hypotenuse, which is 4 over 5. And tan is opposite over adjacent in terms of angle A. Opposite and adjacent, opposite over adjacent is 3 over 4. Now when I go to do angle B, I'm going to redraw the diagram so you won't get mixed up. Let me show you. So here's the diagram in relation to same diagram, but now I'm looking at angle B. So I'm looking at angle B. This is still the hypotenuse, but this is opposite and this is adjacent. So in terms of angle B, hypotenuse is still the hypotenuse in the triangle, but the opposite and the adjacent changes. So in terms of angle B, sine is opposite over hypotenuse, so that's 4 over 5. The cos of angle B, cos is the adjacent over the hypotenuse, which is 3 over 5. And the tan is opposite over the adjacent in terms of angle B, opposite over adjacent is 4 over 3. That's how I work the ratios out. And you keep writing down SOHCAHTOA. Hopefully you won't make an error. And let's do some more example. But this time I have some letters. So, find each trig ratio, and we have a triangle. Notice, angle R, we have a small r, angle P, we have a small p, angle Q, we have a small q. The letters are opposite the angles. Don't have to be all the time, but that's what I'm doing here. And I want to deal with angle R first. There's angle R. So in terms of angle R, this is opposite, that's adjacent, and hypotenuse. So the hypotenuse is Q, opposite and adjacent. So the sine of angle R, and I write down SOHCAHTOA, S-O-H-C-A-H-T-O-A. And I'm doing sine is opposite over hypotenuse, so it's R over Q. Cos is adjacent over hypotenuse is P over Q. And tan is opposite over adjacent, R over P. And if I want to do angle P, again, I do angle P. If you rub these out, you can put opposite, adjacent, hypotenuse like that, but if I'm going to do angle P. So if this is angle P, this is P, Q, and R. In terms of angle P, this is still the hypotenuse. This is opposite side, and this is the adjacent side in terms of angle P. So the sine of P, sine is opposite over hypotenuse. P, opposite, is P over Q. Opposite over hypotenuse. Cos is adjacent over hypotenuse. Cos is the R over Q. And tan of P, tan is opposite over adjacent, so it's P over R. Okay, and I have the word practice here, and practice means work out, do each one, do one at a time to see if you get all the right answers. Doing one at a time ensures everything is okay, because if you don't get it right, you can always check, because if anybody takes a sheet and does all the problems, then if they make an error in the first one, they could be making the same error going through, doing one at a time. Find each trig ratio. Here's angle H and F. I didn't need the right angle. I have a 13, a 12, and a 5. So in terms of F, I have the hypotenuse. In terms of F, that's opposite, and that's adjacent. So sine, SOHCAHTOA again, S-O-H-C-A-H-T-O-A. Always write it down right in front of you, so you don't have to go looking around. And it's a good memorization, writing it down every time. Sine is opposite over hypotenuse, so it's 12 over 13. Cos is adjacent over hypotenuse, 5 over 13. And tan is opposite over adjacent, so it's 12 over 5. And in terms of H, well, let's just not get mixed up. Let's draw H here. Put 13, 12, and 5. In terms of H, that's the hypotenuse. That's opposite. And that's the adjacent. So sine is opposite over hypotenuse, which is a 5 over 12. 5 over 13, sorry. Opposite over hypotenuse. Cos is the adjacent. In terms of H, adjacent is 12 over 5. Sorry. 12 over 13. So let's just go back to make sure. Sine is the opposite over hypotenuse, so it's 5 over 13. Cos is the adjacent over hypotenuse, so it's 12 over 13. And tan is opposite over adjacent, which is 5 over 12. And we have another triangle, and again we do SOHCAHTOA. SOHCAHTOA is SOHCAHTOA. And we're doing D first, angle D. D, this is opposite. That's adjacent. And that's hypotenuse. So in terms of angle D, sine is opposite over hypotenuse. Now, if you think I would know this, right? I do, but why do I make what I call this errors? Make these errors. It's probably because of my learning disability that I have, but I overcome it by practice, practice, practice. Again, in terms of D, this is opposite. That's hypotenuse, and that's adjacent. I should fill in the hypotenuse first each time, but sometimes I forget, and I just do opposite and adjacent, then the hypotenuse. But if you fill in the hypotenuse first, the other two legs got to become opposite and adjacent. So sine is opposite over hypotenuse, so it's D over E. Cos is adjacent over hypotenuse, so it's F over E. And tan is opposite over adjacent, so it's D over F. And I want to do angle F, so let's reproduce the diagram. And F angle, let's reproduce it as it is there so it won't get mixed up. Keep it. So that's an F, that's a right angle. And this is E, that's F, and that's D. So in this triangle there's the right angle, so that's still the hypotenuse. F is this angle here, so that's opposite, and D is the adjacent. So the sine of F is sine is opposite over hypotenuse, so it's F over E. And cos is the adjacent over the hypotenuse in terms of F. Adjacent is D over hypotenuse E. And the tan is opposite over adjacent in terms of F. Opposite is F. D is adjacent, so it's F over D. Okay, so that's working out the trig ratios. Again, just be careful. Again, fill in the hypotenuse first, and the other two legs are the opposite and adjacent. Get used to that. And write down SOHCAHTOA every time. Now another example. I got another example because this is a little bit different. Find each trig ratio. So I want to find, this is angle X, this is the right angle. So what I have here, this is angle X. So these are all in terms of angle X because I only have one angle mentioned. So in terms of X, this is opposite. In terms of X, this is adjacent. But notice I have no hypotenuse. So in order to do sine, SOHCAHTOA, SOHCAHTOA, in order to do sine, I have to have opposite over hypotenuse, but I don't have an hypotenuse. So in a right triangle, C squared equals A squared plus B squared. C is the hypotenuse, so I don't have an hypotenuse. So I have a 24 and I have a 7. So C squared and 24 squared is, let's see, pick up a calculator here, and I got 24 squared. I could multiply it out, but it's just as quick to use the calculator because I don't have 24 squared memorized. 24 squared is 525. 576. 7 squared, 7 sevens are 49. So C squared is, you're going to add on the 49. You're going to get a 625. So C is the square root of 625, and that gives you a 25 when you do the square root. So now we have a 25 for the hypotenuse. So that's the hypotenuse that I had to figure out. And now I can do sine is opposite over hypotenuse. So it's sine of x, opposite is 24 over hypotenuse is 25. Cos is the adjacent over the hypotenuse. And the adjacent side is 7 over 25. 7 adjacent over hypotenuse. And tan is of x is the opposite, which is 24. Tan is opposite over the adjacent. And so that's opposite is 24 over adjacent 7. So notice I had to work out the hypotenuse in order to do the ratios. I could have done tan because in relation to x, I have the opposite and adjacent here, but I had to get the hypotenuse to do sine and cos. Okay, let's continue. Practice means you have to work out these ratios and see what you're going to have. Okay, here we go. Practice. Find each trig ratio. Find the sine of A, the cos of A, the tan of A. So, again, if we do SOHCAHTOA, sine, SOHCAHTOA. So, sine is opposite over hypotenuse. Sine is opposite over hypotenuse. So in terms of A, I don't have my opposite. Again, I got to go. C squared is A squared plus B squared. C is opposite to my right angle, so that's 25 squared is 24 squared plus, and again, I can call that an X or a B, leave it as your choice. So 25 squared is 625. 24 squared is 576 x squared. So if I leave my x squared right where it is, this is 625, subtract 576. So that becomes, when I subtract that, I get a 49. So 49 is equal to x squared. So x is the square root of 49. So x is 7. So I'll put a 7 here. Now, in relation to this triangle, 25 is the hypotenuse. In relation to angle A, this is opposite. In relation to angle A, this is adjacent. So now, sine is opposite over hypotenuse, so it's 7 over 25. Cos is adjacent over hypotenuse. Notice I read it out, I put it down. So the adjacent side for angle A is 24 over 25. And tan is opposite over adjacent, TOA, T-O-A. And in relation to angle, no, we only got one angle, so I really, it's in terms of angle A, so it's 7 over 24. Opposite over adjacent. Okay, let's continue. And we have another triangle, and we want to work out, we have a right angle. So we got to find, is in terms of W. W is the only angle given. So again, SOHCAHTOA, S-O-H-C-A-H-T-O-A. And sine is opposite over hypotenuse, opposite over hypotenuse. So I don't have an hypotenuse. So I'll put an X here, and I'll work out the length of this side. Remember, in terms of W, this is opposite. This is adjacent. And I'm going to work out my hypotenuse. C squared is A squared plus B squared. So the hypotenuse is X, so it's X equals 6 squared plus 8 squared. X squared, 6 squared is 36. 8 squared is 8, 8 is 64. X squared is equal to 100 when you add those two. So X equals the square root of 100. So X equals 10. So put 10 in your diagram in the place of X and call it hypotenuse. Now, what's sine? Opposite over hypotenuse. So opposite is 8 over hypotenuse is 10. And notice 8 over 10 reduces to 4 over 5, dividing by 2. Cos is adjacent over hypotenuse, So in relation to W, adjacent is 6, hypotenuse is 10. And that reduces to 3 over 5 by division, by 2, reducing it down. And W is tan. Tan is SOHCAHTOA, is opposite over adjacent. So that's 8 over 6. And 8 over 6 reduces down by 2. 2 and 8 goes 4. 2 and 6 goes 3. And that one is done. Number 3, we have a triangle, right angle, and we need to find sine, cos, and tan in terms of, I left off the angle K right here. Let me put the angle K in. Sometimes, no matter how many times you proofread, there's always something you miss, because I'm the only one doing all these videos and organizing things. So I have a tendency sometimes to slip on something. If I do, just bear with me. And we have, in terms of K, this is the hypotenuse. In terms of K, this is the adjacent. So, and this side is opposite, but we don't have that side. So again, and I think about SOHCAHTOA, SOHCAHTOA, SOHCAHTOA. So we need to get this side, which is opposite. Because to do sine, I have to have opposite. Sine is opposite over hypotenuse, so I need the x over the 26. So c squared is a squared plus b squared. The hypotenuse is c, which is 26. A is 24. And b is the x. So 26 squared, do that on your calculator, 676, and 24 squared is 576 x squared. So again, I'll leave the x squared where it is and go 676 minus 576. So when you subtract that, you get 100. So that means x is the square root of 100. So x is 10. And so this side becomes 10. Okay. So sine is opposite over hypotenuse. So opposite is 10 over hypotenuse is 26. But we can divide by 2 to get 5 over 13. Cos is the adjacent over the hypotenuse. And the adjacent is 24 over hypotenuse is 26. Again, divide by 2 and I get 12 and 13. And tan is opposite over adjacent. So opposite is 10 over the adjacent, which is 24. And that reduces to 5 over 12. And that's working out the primary trig ratios. As always write down SOHCAHTOA. Always identify the hypotenuse first and opposite and adjacent second. If you don't have all three sides, then do your Pythagorean to work out the other side, and then do SOHCAHTOA, and always reduce fractions. Oops. Okay, sorry about that. That page just slipped in there. And if you like my video, click on the like button, subscribe button, and notification bell. Visit my math website, mathfullyexplained.com, to find more information about me, my videos, and the content on my YouTube channel, Math Fully Explained. Thank you for viewing my video. Bye-bye.